Good morning.
I've got a bowl that just needs to go in the sink.
I have coffee.
Yeah? Can I spend emptying dishwasher now or not?
No, I'm just listening. Sorry. Okay.
Can you hear us?
Yes, apparently you can hear what's happening in my kitchen too.
Well, it's in the background. It's fine. It's good morning sounds. Gotta fix those little tags. They're too big.
I can.
Mm-hmm. Give me a second.
All right.
Oops, now they're a little small. That's okay. So the question I have is, I wonder if people can hear the SEM pump anymore or not with the noise gate I put on it.
Hey, good morning. I just got my chat window open.
So today I thought I would look a little bit at the diatoms from Jackson Lake, Wyoming. They are part of a project that I'm working on with Dr. Mike McGlue. And his PhD student sent them to me. So I've sort of been imaging them a little bit.
Interesting. So I'm having a hard time hearing you. I don't know if it's just me. Maybe it's just me. Maybe it's just me.
Hearing me through Twitch or hearing me through the actual channel?
Hearing you. Rams Reef said, just low. Discord must be low. I think maybe it's, you hear them. You hear us both. And what is it that I did? It's just me.
You can turn up and down the volume in Discord on a person, so maybe you turned me down. Like if you double click on me. So this is a diatom diplanese. It's an internal view. And I'm sure I could tell us what the species is off the top of my head. Low battery.
Sorry. Yes, we have our phones speak to us. There's a visually impaired member in our household, so everything in our house talks to us when there's a problem.
You have a low battery. Okay, I think that looks good, and I'm gonna just go ahead and collect it as an image here. Hey, little Chook, how are you doing? You can hear both of us? That's good. Can you hear the SCM pump in the background, or is it just quiet when I stop talking? Sort of curious about that. I put a noise gate on the microphone to see if it would clip it out. So it's
Oh,
quiet.
you know what? I bet it's the noise gate I'm hearing because it cuts out. It's like you'll speak and there's a beat that cuts out and then it cuts back. Maybe it's just that's what I'm hearing.
Could be. Yeah, I don't know how it interacts with the Discord channel, but it could be that. I suppose I could make some noise before I actually start talking, and then it will keep from clipping me.
Diplanice. Oh wait, you have a new toy when you come up with a when there's a diatom, right?
Oh yeah. You should just be able to type any genus. I think it's exclamation G and then like Diplanice. There you go.
Huh.
Did it work? It looks like the link came up.
It
did.
It did. There's a link and everything.
Pretty cool, right?
It is. Let's see if I can do it. Of course, I have to spell.
Well, if you type it wrong, it just takes you to nothing. So
Yay.
it worked. Yeah, that's cool, right? A little bit of coding on my end.
It is.
Took me like 10 seconds to make. I think there's only 2 genera it doesn't work for on the Diatoms of North America website. So as long as we don't run into those 2 genera, we're fine.
Ooh, on the diagonal says it sounds like a rumble while you're talking or typing, but when you stop talking, the rumble disappears and goes silent.
Yeah, that's the vacuum you're hearing behind me. So I just have a noise gate that clips out the vacuum noise, but whenever I talk, the microphone is hot, so it just picks up all the sound.
I kind of miss the vacuum noise.
Oh, you want me to bring it back?
I'm not, it doesn't matter what I miss.
I guess I could just talk a lot and then you'll still hear it.
True. So Jackson Lake in Wyoming. Have we looked at these before on stream?
Just briefly, I had them on one day where we were looking at the Stephanodiscus, which is the dominant diatom. It's this giant thing right here. And I think I came to the conclusion that it was Stephanodiscus niagara, but there's a whole sort of fuzzy collection of things that kind of belong to the species Stephanodiscus niagara. And so I just wanted to kind of like check it out and see which characteristics are there.
You're getting, let's see, Manning 420 says they should send you uglies from their saltwater aquarium, and Rams Reef has said they'd already offered. You're getting sample offers in chat.
Well, you're always welcome to send me stuff. And then I guess I have an option of putting it on the SCM or not if I feel like it. Um, yeah. I mean, if it's something cool, I'll definitely put it on the SCM. I don't know about uglies. What's an ugly?
I don't know. It's the yucky mucky water, maybe? Ram's
Oh,
Reef is suggesting something from skimmer juice.
that probably would work actually. It'd probably work pretty well. That's on my koi pond. There's a fountain and a filter that feeds into the fountain, and occasionally will scrape that filter, and you can get a pretty good collection of algae from that. So
Nice.
it's a fair approach. Yeah, so these big round guys that you see, they're pretty huge, are the Stephanodiscus nigeri.
Look at those spines.
Yeah, they're pretty glorious. And there's one over here that was on its side, so you could kind of see how, yeah, here it is. You can see how big they are and how high they stand up off of the actual surface if I focus on them.
I was going to say, they just kind of look normal size to me.
The diatoms?
Yeah.
Well, it's hard to get perspective, I guess, but relative to the rest of the things that are in here. So here's a good view. That's Stephanodiscus nigeri, and this is a typical centric diatom in freshwater systems over here. This is Lindavia intermedia. And so this is 30 microns across or something like that. So that's kind of like an average size for, 27. Pretty average size for a freshwater plankton. And then there's some little guys in here too. These are Olicocyra. But you can see the diameter for those is like 9. So
Much smaller.
yeah, when you're looking at this and it's like 80 or 50, these ones are almost 100 across. So yeah, that's pretty normal for the marine realm to get like into the hundreds, but for the freshwater realm, it's pretty uncommon. It happens obviously, but then there's some stuff in like Tanganyika that's even bigger than these. But generally speaking, the plankton's a lot smaller. So, and that's largely related to probably wave energy. So little diatom diameters mean that they can handle, bigger diatoms would have a harder time staying afloat, basically in lower wave energy. So the outside of a Stephanodiscus is pretty interesting. And these ones are good examples of them. You can see they just have kind of simple pores on the surface. And they're in sort of bundles, rows of bundled pores, which we call fascicles, or Stephanodiscus and things that are kind of similar to it. And then you have these big spines. So I'm going to slow it down. You can see the big long spines are all basically at the same height or position on the valve. And then these things that you see, the little tubes that are in between them and basically not at the same height, they're just recessed a little bit in terms of their position. Those are the external tubules associated with the rim of Portula. So on the inside, you'd have little lip-shaped processes that would be associated with each one of these. So here's one, here's one, here's one. They're all over the place on the outside of this thing. And then if we were to look closely, subtending each one of the actual spines, which are the longer ones, you would find a little process sticking out. You can see them here pretty easily. So I'm going to try to zoom in on that so you can see them. And this is a good view because it kind of shows you all of them at once. Here's the spine. It's solid and has like a little sort of knob at the top of it. And then here's the Rhizoportula process. It's not at the same elevation as the spines, but a little skinnier, and an actual tube, which you can see if I focus right at the right height here. You can see this little opening. And then these are the external expression of the mantle photoportula. So there's actually a hole that goes through the valve associated with these ones and with this one, and these are just ornamentation that are on the surface. So if you if I zoom out again, you'll see that occasionally the spines get knocked off, and so there'll be just like a little here, like there's a little piece of silica hardened where the spine would normally be. I'm just gonna take a zoomed out photo of it. And so we have all the features, and this is a nice big one, and it's mostly clean from debris. There's a little junk on it, but there's always a little bit of junk on everything at this level. I think that looks good.
So how is this one different from the one that was mentioned in the article about Mark that you posted on your Discord?
Oh, so that diatom that Mark was talking about is the one that that Mark and I described last year, and it's from June Lake, which is actually not that far from Jackson Lake. I mean, relative to most things, but farther south, and it's in the Sierra Nevadas. So if you were to look at it closely, if you were to look at that image that that Mark posted associated with it, you'd see that the areolae, which are the little holes on the valve face, and their bundles have a much wider sort of pie wedge sort of number of holes in a row between each one of the bundles. So on this diatom, for example, in here you can kind of see these solid lines are the interfascicles or costae, and then there's just 2, and then they become 3, and then out here they turn into like 6 or something between each one. But on that other one, the shape of those is actually much wider, and then they have a similar looking spine to these, but they're much smaller diatoms too. So if you just looked at the maximum size range, they never get up into the 90s, or not 96 at least. So and then it's mostly those sort of characteristics. But if we were to look on the inside of this diatom, it would be a lot more obvious, because these are the mantle photoportula, and for all Stephanodiscus there are a spine, and then beneath the spine is a mantle photoportula. So this relationship is present in all Stephanodiscus, where you have a spine and then you have a mantle photoportula that's underneath it, although it isn't always 1-to-1. So sometimes there's more spines than mantle photoportula, for example, but if there's a mantle photoportula, it's supposed to be under a spine. But there's other structures that occur in here on this diatom in the center. For the internal view, we can't see them because they're not really distinct pores associated with them on the outside. So I'll get an internal view, and then it'll be a little bit clearer. But those are the valve face photoportula, and there are no valve face photoportula on the diatom that Mark and I described. There's zero ever. So that's one characteristic that's pretty distinct, and that's a consistent feature for a lot of diatoms. So if I can find one.
Nice. I put the link in chat for the article
Oh, perfect.
about that living fossil.
Yeah, and let's see, maybe this one is an internal view. It kind of looks like it could be. Kind of a small one, but here, these structures, they look like this one has three little holes, and this one has 2 little holes associated with them. They're a little muddy, but if I slow the beam down a little, you can see this is the areolae that we were seeing on the outside. They have sort of a domed salt and pepper-like structure, shaker structure on the inside, and then there's this thing that looks different, and that is a valve face photoportula. And this one has 2 satellite pores, so it has one central hole, and then 2 sort of, I don't know, Mickey Mouse ears or something associated with it. And then if we were to go look at this one over here, it has one central hole, and then it has 3 little Mickey Mouse ears associated with it. So these are valve face photoportula. In other words, there's one hole with 2 satellites or 3 satellites, and sometimes there's 4 or 5 satellites or whatever, depending on the species. But this species has either 2 or 3, but they're on the valve face. So they're positioned off of the edge of the diatom. So it's a bottle cap. It's the flat part of a bottle cap, right? So you can see there's a bunch of them actually, and that's common for this group. I don't know, put it in this sort of range. You can see there's one here, one there, there's one down here, here's one. And in this case, they're all roughly equal distance from the center in this sort of a ring right here. It's not perfect, but, it's close enough. Yeah, there's 0 of these. They never occur on the valve face in the Stephanodiscus that we have. So aside from the size issues and the sort of thickness of the costae and the width of the sort of fascicles, they don't have this process at all. This is a Olicocyra, and these are separation valves. So the little spines that are here are meant to let go, basically. And this is one valve. This is the other half of the same cell. So these 2 valves together make one whole diatom. And then this one here is a little half diatom. It's just being held on to by this spines that are supposed to be letting go, but these ones didn't, basically. They don't always separate along the separation spines, they just can. And some Olicocyra never make anything but separation spines, and some make linking spines and separation spines. It's kind of an interesting little thing. I think this is actually a initial valve for that Olicocyra. And I don't know that I've seen any of these before, so that's kind of cool. And definitely not in these samples. And I want to play around with my stigmation just for a second here and see if I can get it a little bit better. So diatoms, after they undergo sexual reproduction, will, the first round after that, basically they start with a hemispherical shaped valve, which is what we usually call an initial cell. There's actually something called an oxyspore, which is the actual, like, I don't know, egg that is made when they undergo sexual reproduction. And then it silicifies underneath the sort of egg wrapper, and it produces a completely spherical valve for centric diatoms. And then it starts to split, and when it splits, basically, it starts making normal valves. And so I think this is a initial valve for that Oligocyra we were just looking at. So as if things weren't confusing enough, there's a potential to have some odd-shaped valve in any diatom population that you're looking at that doesn't seem to have any real relationship with the other diatoms, except for it looks like an Oligocyra to me. It just doesn't have any of the shapes of Oligocyra. It's hemispherical, so bound to be confusing to any person.
So do they only make those after sex?
Yes. So the normal reproductive process is for Oligocyra, they're living in chains. So they don't, you should never find them just basically off on their own. And then when they switch to sexual reproduction, usually they'll grow the oxyspore at the end of the chain. So sometimes you'll see like a whole chain, and then there'll be like a big globe stuck on the end of it, which is an initial valve that just hadn't completely separated from the chain yet. Either if it's the first one, they'll all be the same size as the initial valve, and if it's like just as it's actually undergoing the sexual reproduction, it'll be like a big ball on the end of a long series of skinnier valves. So I've seen that before, but I've never seen this, where the initial cell is just like one valve just broke off and is sitting on the, cup down on the SEM stub. So, and there's not a lot of Oligocyra in this sample. I mean, they're present, but normally it helps if you have a lot of an organism in order to actually capture like one of the initial valves. So it's sort of cool that they're pretty rare in the sample, like maybe 20% of it or something. But I usually only find initial valves if the diatom is like 80% of a sample or something, because they're just infrequent. If you think about the process of asexual reproduction, where organisms can just keep splitting and splitting and splitting and splitting, the rarest thing in the entire population is actually the initial valve, right? So the first one in that series after sex is this odd diatom. There's only one of them, and when it splits, one valve fragment like this, one half of a valve, gets stuck on one end of the chain, and one gets stuck on the other end of the chain, and then it just makes a giant chain in between them that continues growing indefinitely. So you're looking at something that, like if each diatom can duplicate maybe 28 times before it dies, and then each subsequent cell can basically replicate something like 28 times before it dies, a typical population might be hundreds or thousands of diatoms, well, at least valves. And then you found one of these sort of things, there's only 1 in 2,000 or 1 in 1,000 or something of them, right? So it's like winning the lottery a little bit. It's kind of cool. I didn't get any money, but I got this cool picture out of it.
It's great.
So my grad student Laura has been sort of training on how to use the SCM. And that's just a girdle band, by the way, floating out by itself. And here's one of these Oligoceras just landed face down. And that's a Chrysophyte Cyst, a stomatocyst. Trying to see what that was. So she's been sort of learning how to use the SCM, and I had her looking at these samples because we needed some photos of stuff for Mike and his student, and she needed some time on the SCM to sort of learn how to do things. So I thought, oh, this would be a good opportunity to kind of like, you know, optimize, get a little something done for everybody, and then despite spending hours doing this already, there's still a bunch of stuff that we haven't imaged in these samples. So, I mean, that's one of the things about the SCM is, as I'm sure you're aware, it just sort of like time just sort of sinks into it, and no matter how fast you are at it, you still have a hard time like characterizing population.
What's that one?
I'm not sure what that is actually. I'm sure it's a diatom. It's a piece of something. So, and I can't see into it to actually see what it is. So a question mark for me. I think that's a Chrysophyte cyst right there. Just the aperture's down here. And I have a fascination with Chrysophyte cysts because they're always found in diatom samples that in the lakes that I look at. But I don't know them. You know what I mean? Like I can tell it's a Chrysophyte, but I don't know what kind. And so I always feel like I should try to learn it. To figure out what they are. But I never do, because it's, you know, like I have a specialization, and that's a whole separate specialization. So, you know, maybe when I get a little older and I have a little spare time. This is a Fragillaria. I think it's Voucherae, the species. That's an internal view of it. It's got some mud in it. The sample's a little bit muddy. I think we rinsed it a bunch, but still didn't get all of the mud out of it. I saw something over here that's kind of interesting, so. Not sure what this is either. Planethidium, maybe? I think it's a monoraphid diatom. Because there's a gap right here, and it looks like it's a horseshoe shape. Hufeisen is the diatom word for that structure. Or sometimes just called a...
Raul SP Guber says, greetings from Spain.
Oh. Greetings. Welcome in. One of the nice things about streaming when I do is that it's available, at least on a somewhat reasonable level, for people in Europe. Unfortunately, I can't hit everybody all the time with respect to like time frame and Jay Renzella is in Taiwan, for example, and it's just never in his time zone. So just trying to rotate this thing around so I can get a little closer. And as annoying as these little things are that are kind of hard to identify, it's kind of what the SCM's for. So it may not look very spectacular relative to some of the other things that we put on the SCM, but more often than not, it's these little things that you need to image that are maybe a little less exciting, but it comes down to like somebody really needed to see those little tiny structures and try to figure out what this thing is. Typically, we need the SCM more for that than we do the monster Stephanodiscus, although that Stephanodiscus probably does need to have some SCM work on it in order to figure out where it belongs with the Niagara group. But this tiny little guy, this tiny little monoraphid, I'm going to guess that Mike's student's going to appreciate those pictures more later. Yeah, and Jay Renzella is actually doing some dual draw with one of his friends on a stream on Sunday. I think it turns out to be Sunday night for us. For me, it's like 11 o'clock on a Sunday night. For you, it would be like 8 o'clock on Sunday night. You're in Pacific time. And they're drawing, they've collected some images from both me and Pacific Plankton, and they're using those as the, what do you call that, reference or something? Something to stare at while they draw. So if you're interested in checking out some of the artwork, that'd be a cool thing to check in on.
Yeah, it's a draw along he's doing with another streamer on Twitch.
Yeah, and they told me that I should also try to draw along. So I guess maybe you could too if you're going to be around. But
I am. I'm so excited.
it'll be a lot easier to draw them if they're not wiggling around and stuff. So, hey, Pandemic, how's it going? We're collecting pictures of diatoms on the SCM, as usual.
Collecting them like Pokemon cards.
Yeah. Well, normally when I start a project, my recommendation also for students when they start a project is that I just have them go through all the slides and take pictures of everything, and then work on getting enough pictures of each organism that they can identify it. And that actually sometimes takes a little bit more than 3 or 4 photos of each specimen. Is it by Jackson Hole? Yes. It's in the Tetons, the site is. It's a really spectacular lake. If you just Google Jackson Lake, it'll be the first one that comes up probably. It's a really gorgeous looking place. I probably should have put some pictures into the slideshow of it, but that would have required a little bit more preparation than I actually did.
So Pandemic Watch said they read recently about some steer driving controversy into Jackson Hole long ago.
Steer driving? Like cattle ranching? I don't know what steer driving means. I'm not up on the lingo.
Yes.
What's the controversy?
Apparently some giant feud for food need fuel.
Huh. Okay. Yeah, I don't know anything about it. These samples are collected from some cores, so they were something that Mike and his students collected. Dude, what's going on here? There's something weird going on. What the heck? I don't understand. There's like a ring right here. That's not supposed to be there. I'm confused what that is.
It's a mistake.
It's a fairy ring. It could be a mistake. It could be a teratological deformation of some type, but just confusing to me what it is.
Okay, teratological.
Yeah, that's a fancy science way of saying circus freak. It's like a oddity of nature, and it's what happens when the organisms basically are aiming to make their valve correctly but fail to. So we just refer to them as teratological deformations. There's some sort of like structural failure when it was sort of constructing the diatom. But I'm confused because it's like a ring of spines that don't belong to it, that are just in a ring here. Like a Stephanodiscus fell on the sample and then just dropped all of its spines right there and then dissolved. That's what it looks like. I don't know. It's super weird. This thing that's behind it, however, also I don't know what it is because I haven't seen a lot of the plankton. And I'm confused what all these pieces are that are on here. They don't look like they belong. But I think that's a Reproduction, which is also weird. Because this looks like it belongs to the Cyclotella group, and that's not supposed to be where they put their Reproduction. So, super strange series of things going on. Hard for me to figure out what it is supposed to be doing versus what it is doing. Also don't know
Well,
what these
Pandemic
things
Watch
are.
has some suggestions. Perhaps a completely dissolved smaller diatom, nearly completely.
Yeah, it could be. And then maybe this is the Reproduction that belongs with the actual Cyclotella. And that's a possibility. And this is just the Reproduction also got left behind and it dissolved? I don't know. I guess we'll see. This looks like it actually is the correct... That looks like it's a Reproduction that where it belongs, but... this thing is... It's like bits and pieces of diatoms in the right place, but there's no skeleton. Yeah. That's the Reproduction, I think, for this thing. But maybe not. Maybe it's just a piece of clay. I don't know. There's a valve-faced photoportula here. Can't tell if it belongs to this thing or the thing that got like left the spines behind. Super weird. It could be that there's a pile of clay on top of this as well that's covering over stuff, but it doesn't look like it. It looks like they're just laying there. It was just very lightly silicified and hit the surface and just like evaporated. Super weird. Okay. Well, I'm gonna fixate on it too much. Looks like when somebody was putting the sample on, like on the actual carousel, they bumped it or they turned it sideways and one of the diatoms actually fell off of it. So maybe that's also... There's a shadow where a diatom was. Just a ghost of the diatom's past. These, you can see those spines have really cool little tips on them. This guy right here is Syneedra Cyclopam, and it's a interesting diatom. It grows on, it's epizoic, and that means it grows on an animal. And this one grows on the outside of like ostracods and daphnia. Look at the spines on this guy. See why there's like a piece of junk right there and some junk right there. This would have been really pretty. Lay on the top of it.
Spinetacular.
Yeah. Had a lot of spines. You can see there's some more missing diatoms right there. It's like little shadows where the diatoms were. Somewhere there's gold-plated diatoms laying on the floor of the lab here. Somebody bumped my sample and knocked them all off. Pretty funny.
It's like you need a really, really tiny metal detector so you can like go around and all of the gold-plated critters.
There's probably more than just diatoms. So that might be, you know, I don't know if I did that on stream. Maybe Dr. WD-40 would feel like I was infringing on his thing. I have little like gold-plated diatom hunting parties. That would be funny. There's a little tiny guy. This looks like the pieces of the thing we saw, right? Little tiny stuff. Got dirt all over the outside of it, of course, but it has tiny spines. So it's another example of a Stephanodiscus. You can see the ring of spines, and they're in rows at the end of each one of these, like a bicycle spoke. And I would guess, although I can't see it, that there's a little Mantophotoportula out here on the edges of these things. So this is a different species. It's way too small to be Stephanodiscus niagari, which is that big thing. And but it's nice for comparison, so you can see that's a Stephanodiscus, and these things out here, these giant things, are also the girdle bands of these big Stephanodiscus. So it's something that happens pretty commonly, actually, with where I find Stephanodiscus niagari. Usually you also find some little stuff in that same environment. It's pretty frequent occurrence for me. Co-occurrence, I should say. Those are Oligocyra valve faces. These are all Oligocyra. Not really sure what this thing is. Keep seeing something like this in girdle view. It looks like maybe it's a Melocyra. It doesn't have any of the ornamentation of an Oligocyra. It's the pieces of the girdle band and the outside of the valve right here. And those are probably Rhemoportula slits associated with Rhemoportula for the organism. And then, you know, it doesn't have all the structure of Oligocyra, but it has the shape of a capsule like Oligocyra does. So it's probably Melocyra. See if
It's so smooth.
Well, it seems smooth until I slow it down, and then you'll see that it actually has a lot of stuff going on. It's just that the girdle bands are kind of wrapped around it, and we can see the sort of divisions in it right here, the girdle band divisions. Like here's one, and here's another. Where they're basically, you can see the sort of bands themselves are pieces of it. You see the little slits right here that go around? It's really fine. And then here's another piece of a girdle band. You can see the bands themselves. The individual components of the band are obvious. If I can change the brightness and contrast so they stand out a little bit more. But you can see on the valve face there's actually a little bit of structure. And this is a typical Olicocyra right here from this set. The spines are pointing at us. That's the valve face. So it doesn't have any spines. It doesn't have the big pores associated with the mantle that Olicocyra have. So, back in the day, I guess it was probably the 70s, all of the Olicocyra used to be called Melocyra, which is, I think, what this thing is. And so they used to be considered the same genus. And then someone came along and said, well, it's got all these characteristics that are kind of different than Melocyra. And so they broke them out into their own group. And they broke out actually a bunch of these little sort of capsule-shaped things. Ellerbeckia used to also be lumped in with these. And a whole bunch of, like, all the little round things that were kind of capsule-shaped were all basically stuck in Melocyra. And you still see that in the literature sometimes. People use the old genus names. Usually it's because the guidebook that they're using, like the Flora Key or whatever, has the old names, and so they just apply the old names.
It's interesting because the sound that comes out through the stream is so much smoother.
What do you mean? Without the vacuum noise?
The sound. No, the sound gate actually breaks up the sound in Discord. So I miss more in Discord than I do when I'm listening to your stream.
Oh, okay. Yeah, it's just something to do with, maybe Discord has its own filter that it's putting on there. I guess that's a positive, because it means the people out there listening aren't missing it, but unfortunate for you.
Pandemic Watch says they just learned recently there's a group above kingdom. Mind blown. Kingdom, phylum, class, order, family, genus, species. Now there's one on top?
Yeah, they had to move up a group, yeah, domain. I don't know. They have to, they shuffle things around so much, yeah. Life, yeah. It's like rocks, life. They end up shuffling stuff around quite a bit. And then I think they just realized there wasn't enough room up at the top. Yeah. Right, Archaea. Yeah, they screw everything up. Yeah. Well, I mean, they've been on the scene for a while. People just didn't know where they belonged. And some of the divisions that they had, they just, I think they weren't working for people, so they had to open up another layer above. Pretty cool. Little image. I think this is Mellocyra varians. I'm guessing that because every time I ever look up Mellocyra in freshwater systems, it's basically Mellocyra varians. So I don't think that there's very many species in the freshwater realm that belong to that group, but they do occur in the marine setting, and they've got their own species basically that fit into that group that are common in marine settings. And then there's this sort of stuff like you get, which is basically things that get carried from freshwater into the marine settings as well. But I think there's like strictly marine or brackish species too. This little guy, another Chrysophyte cyst. Nope, that's an Oligocyra top view. This one though? Yeah, that's a Chrysophyte cyst. You can see a little bit of the aperture over here. The surface of it has just no texture, just totally smooth. I can't even figure out what's in focus and what isn't. Kind of need to like have the edge of it in order to even tell. Here, you can see a little bit of the aperture right there. The rest of it's just completely smooth. So
And there's a diatom on its side there right next to it. What's that?
this one? It's
Mm-hmm.
yeah, it's an acanthidium.
Ah.
Acanthidium, probably in the Minutissima group. They usually have like an inchworm appearance. So I'm pretty sure it's acanthidium. If the raphe is on this valve, the one that's broken, it's acanthidium. If the raphe is on this valve, because they're monoraphids, I forget what that puts it in. Samothidium, I think. It's another Chrysophyte cyst, I believe. Little round guys with nothing, with no distinguishing characteristics, except for the aperture, which we can't see. That is, I think, an internal view of that Stephanodiscus, the little tiny stuff that we saw. Although, hold me to that. It's covered with a lot of junk. This one's on its side. You can see all the spines super well sticking off of the valve face. They're kind of curled, like eyelashes. And it just landed on its side. Like, you know, somebody flipped a coin and it just landed on the side. This is a Cervarella. And the raphe runs around the outside edge. It's a circumferential raphe. And this is kind of a neat view of the valve face because we can look in these little windows on the sides here. That weird angle. Not sure why my computer dinged at me about that.
Surrella, right?
Yeah, that one's a hard one to spell. Are you doing the genus command?
Yeah, I did. I look it up in Google and then I can copy it in and get it right.
It's an extra step for you. It's like the commands made it harder for you, not easier. All
It's not
the
bad.
all the Latin names are, you know, challenging to spell. Surrella is actually hard to say as well, so it's like not helpful.
Yeah, when I say it, it sounds like I'm slurring my speech.
It sounds everybody like that. There's already a few microscopic YouTube channels out there. Yeah, that's true. Probably people aren't streaming SCM stuff. At least not frequently. All of my actual Twitch content gets transferred into my YouTube channel. Eventually, I archive it there. Although I guess I haven't done that in a little while, so I probably need to get on it. I don't know. You'd think it would be popular, but I don't know that it necessarily is. So, but also I don't really spend a lot of time sort of promoting myself or pushing science. So, just kind of let people come to it, I guess.
That's beautiful. Look at the arches. They're like,
Yeah, it's pretty neat.
structural.
Yeah, they're like flying buttresses, or like the inside of a cathedral, right?
Definitely. I keep unmuting myself and muting myself because there's life in the background in my house this morning.
It's fine. It's probably still better than the vacuum pump noise for people. I don't know.
I'm kind of nostalgic for the vacuum pump noise, but that's just me.
Well, I could ungate it. It's easy to do. Just come into the mic and I hit filters, and I could just delete it. There you go. Now you can hear it. Now you've got the inside of the room sound. Now if my mic sounds funny, it's not my fault. let's jump to one of these other stubs. They're all the same thing, so it's not like it will matter much, but wow, it really went spinning quite a bit for that. Took the samples for a little ride, I guess, because it need to go all the way around. I tried a bunch of different sort of densities when I was putting these together. Probably I should have tried rinsing it again.
So is that clay on it?
Yeah, they all have a little bit of clay and debris. I mean, there's a little bit on all of it. I think the samples have, they came out of core, so usually it requires a little extra processing. I think this is a little Pinularia. And I think I turned it the wrong way. Maybe. Nope, actually I was turning it the right way. Just not enough. There we go. Let's see if we can...
So Pinularia and not Navicula.
Mm-hmm. It's definitely Pinularia. And not Navicula. And the reason that I know that is that Navicula, the areolae, which are these, or the striae, which are these rows of areolae right here, would have lineolate striae, so little lines on the striae. I'll find an example of one maybe later, but these don't have those at all. They have, can't really see it. There's a little bit of clay on the outside edge, so you can't see the pores, but there's just a whole bunch of little like salt and pepper shaker pores over top of these costi that make up the Pinularia's striae, and so they look different. Both in the light microscope and in the SEM. So in the light microscope, these striae just look extra wide striae with no lines crossing them. But you can actually see the linealations in Navicula in a light microscope normally. So, and you'd be able to see it maybe a little bit better than these even, because this has so much clay on the outside of it. It's occluding the surface. Interesting little.
And Bluesy is here. They're
Bluesy?
saying hello. Late to the party, but just like these diatoms.
Yeah. That's alright. Our party doesn't have a defined start or stopping point. You can just come in and hang out whenever you like. We're here. That's a really nice... You can see there's a little bit of clay on the surface of it. It's creating that sort of crackled look. Mud cracks. Appearance of mud cracks. They potentially serve another purpose for me, which is I could play around with the stigmation a little bit if I wanted to.
So what kind is this one?
It's a good question. I'm not sure I know the answer. It's a, I think it's Staracirella, would be my guess. Yeah, it's a little bit better.
Ooh.
The striae come across, but they don't meet with anything on the other side. And the holes that are open are just little tiny single slotted holes. So I think that makes it Staracirella. And then it's got spines on each of the zones in between. And I think if we saw down here, if we looked closely at that, we'd find that's a Rimoportula, or that there's a Rimoportula down here somewhere. Maybe it's on the other end. I kind of like that texture, though, even with the sort of muddy look.
Pandemic Watch says electrostatics at work.
Yeah. Tiny, tiny mud cracks.
And Bluesy says, okay, let me use Gandalf's saying about time. A Bluesy is never late, nor is she early. She always arrives exactly when she wants. And there's my doorbell. I'll be back.
The doorbell was super loud for me. It's like a ding dong. There's an outside view of the Diplonis that we saw earlier. And an external view. All of the samples, just a little bit of mud on them. A little bit of clay. Does this say... Yeah, this is a navicula. So if we actually could see the... Yeah, here, you can see the linealations. So on these ones, the actual little areolae are these slotted lines that are going across. So distinct from pinnularia in that sense. It's nice, except for just a little bit of junk on it. I was really hoping to find some of these other little centrics, the little round guys, that didn't have any junk on them, but I haven't had a ton of luck with that. It's like most of them have some debris, or they're on their sides, or something's on top of them. It's a luxury having somebody to be able to hang out and read me the chat while I'm trying to scan around for things. So I'm gonna probably have to take a picture so I can hear what people are saying.
Oh, I'm back.
Did you get something good?
It was for my mom, so it's hard for her to receive things, so I do it for her.
Oh, cool.
All right. Did you get the cat's always scared by the doorbell from Pandemic Watch?
I'm also scared by the doorbell. When it rang, I was like, whoa. It came out super loud in my ears.
Oh, sorry.
It's all right. I was just like, I better go.
Everything's loud in our house because of our disabled family members. So we tend to have a lot of sounds.
Yeah, it's all right. Just caught me off guard. It's like when I get like a sound alert and I'm not paying attention to, I'm kind of zoomed in on things and not really thinking about what's going on. It's like I forget I'm streaming or whatever else. I have no idea what's going on with this. This is another really
So
weird
Lucy
looking.
was saying, yeah, an Oreo diatom? Treacle?
I wish it was an Oreo. I could use an Oreo right about now. People always start talking about food while I'm streaming. Let's see. Just checking on that focus a little. I guess it's okay. Still feel like it could be better. Let's see if I zoom into here and try to get it just tight in here, maybe.
Is it like a Lindavia or something?
Oh, look at you.
Ha ha.
It is a Lindavia. Unless you're in Europe. The Europeans would refer to this probably as Pentachecula. There's some sort of a rift in the use of terminology for the cycloteloids, and a lot of the, especially with Lindavia, so a lot of the Europeans would call this a Pentachecula, and a lot of North Americans would just leave it in Lindavia, leave it alone. I'm also one of those North Americans. I would leave it in Lindavia, but we all have our bias. If I had to guess, this is Tripartita or Ocellata, I don't know, or Rossii. It's one of these. But that is a really weird looking diatom because it has this like weird ring of, like a weird structural ring in the middle.
Well, Diatoms of North America has it as Lindavia, right?
They do. I don't think they have Pentachecula on there at all. My guiding star in this is usually Andy Alverson, because Andy, we work together and he's looked at a lot of stuff in diatom genetic analysis, and a lot of the reason Pentachecula was split out from Lindavia was based on genetic sort of analyses, and he doesn't agree with what they did. So it could be that it needs to be split out, but it also could be that they got it wrong. So this is like weird. There's like a ring of sort of a ring right here in the middle, at the outside edge, right at the edge of the central area. There's like a ring of little bumps. That's super weird. Otherwise, kind of looks like Ocellata.
Pandemic Watch noticed that. The holes are even more intriguing.
Yeah. Yeah, there's super like holes inside the holes sort of thing going on here. And then there's a positive, these granular structures are positive relief. They would have fit in the holes of the sister valve when it was being generated, so it's also at a weird angle, so we can actually see sort of into the holes a little bit better.
And Bluesy was saying, are they calcium deposits?
No, they're probably silica deposits. When diatoms have an environment that has an excessive amount of silica, they usually put these little nodules, these little granules on the outside of the valve. It's a way for them to steal silica from the environment And this is things that, so I guess I haven't really talked about this much, which is that the diatoms are kind of little pigs, in that, like, I don't know, if you ever have two dogs in a house at the same time, and then you try to feed them, and then they fight over it, or their behavior totally changes. So you put the food in front of the plankton, and the diatoms will start to just consume all of it. They aggressively take up nutrients, and part of that's because they can replicate so quickly. I mean, a lot of algae can replicate quickly, but diatoms are pretty exceptional at that, and they will also hoard nutrients. So that's like they have hoarding behavior. They'll just basically try to get all the nutrients that are available, and then so nobody else can have them, basically. And also, so when they replicate, they could use it to give to the offspring. So when they split, their clones could have some extra silica or phosphorus.
Wait.
What am I waiting for?
They share silica with each other?
Well, the valve, they could potentially dissolve some of this, right? And then when they're making the next valve, they could use it. So, but they will hoard phosphorus, for example, for sure. They do what's called luxury consumption. So if there's phosphorus in the environment, what they will do is take all of it, like every bit of it, will be consumed as much as they can sort of fit inside their cells, and they'll just pack it away. And then, they have it available so they can split whenever they want. It's like basically a little stash of food. And I think they also will stash silica as a result, and they stash it basically in these little nodules. So when they're making the next valve, they could potentially dissolve some of the silica and then use it, right? Because silica is a thing that they actually need a lot of, along with phosphorus and everything else. So if there's extra silica, a lot of times you'll see them have these little granules on them.
Oh, and then Jake Programming is here, and they're curious about the magnification. It says it shows microns, but doesn't tell me what the magnification is. There's a simple way to figure out magnification based on microns.
If you want to know what the magnification is, so let me start this picture for a second, because I want to get a nice picture here. And then this looks like it's going to turn out. I leave open, and I think you can see it, on the top right corner, up here. Magnification. So I think you can see that when I highlight it here. That's actually the value for the magnification. That's 23,000 times. So kx is 1,000 times. And so if you just wanted to know the pure magnification, that's there. If you want to know the width of the view field, it's also up there. So that's basically 15 microns from one side of the picture to the other. Whether that's in the horizontal or vertical direction, it doesn't matter. And then if you want to know what speed we're operating at, or the voltage, or the working distance, we're about 5 millimeters from the sample. Also, it tells us the depth of focus. So if you wanted to know, like, how far before things start going out of focus, like into the actual image, that's what this value is. So it's basically anything that's wider than 2 microns will be start to go out of focus. So all that's basically right here. And you should be able to see all those things on the stream. That's why I leave that box up, actually. But if you were curious about it and you wanted to see it, it's also down here. The view field is down here. And I think when the picture actually completes, it lists the total magnification in the bottom corner. But but I usually you don't see it for very long because I put a label on it and then close it. So yeah, 23,000 times. So in a normal light microscope maxes out usually around 1,000 times. Sometimes people will put special eyepieces on it that will get it up to 1,200 times, but it's usually not. It's not actually making the image. It's making the image bigger, but it's not actually making the picture better resolved. So, making it bigger doesn't necessarily make it better. It's like if you projected this picture onto the wall, the image would be bigger, but it wouldn't be better resolved. So it would just be grainier. So in these you can actually see, here's the costi that come out, and then here is the, this little hole right here and this one right here are associated with the Mantophotoportula. And hang on, I just want to sort of take a look at this.
And then Open Set is here.
Hey, Open Set.
And so is Devil and Mrs. J.
Hey, how's it going, Mrs. J? That's a good image.
And then Pandemic Watch says they would love to see Dino R someday.
Dino R? What's Dino R?
I don't know.
Oh. Just like the letter R?
Oh, Dinococcus radiodurans.
Oh, yeah. Well, I guess I could get some Spam and crack it open and see if we can find some bacteria for you. I can irradiate it and get rid of all the other bacteria. I don't usually look at bacteria, and not in the SEM anyhow, not on purpose. Yeah, I think that other view we had is the best we're going to get, but this looks pretty close to Ocellata. This is a pretty nice, clean, internal view. I don't know about... Yeah, on the edges it's kind of junky, but you can see there's sort of a ring right here. You can see like a whole series of these all together in a ring. Those are all Mantophotoportula. And on days when I feel like the stigmation is really good, I'm not sure we're there yet, if we zoom in on these like crazy level, you can definitely see the strutted process. There's the central pore, and then you can see the little holes associated with the satellite pores that are attached to the outside edge, and then there's sort of like coverings that are over top of them.
So it's not a good stigmation day yet?
It's not bad. It's just not the best.
Open Set says vintage aged Spam from the Special Reserve. And Gluzius says, in the armed forces, we had 40-year-old Spam that was perfectly edible. And Pandemic Watch says, nice or space spanning measure. Oh, spamming, sorry.
Let's see what we can do with this one. He's actually pretty nice. It's like I can't find a spot that doesn't have some junk on it. I want one that's like totally clean. And there's always just a little bit of junk. So this has 2 and 3, 3 and 3, 3 and 2. It's a 2, a 3, a 2. So all of them are in a ring, and there's 2 or 3 of them. So I'm going to just have one sort of zoomed out image where we can see the whole clock of them. As close as I can get them to be inside our image. And then maybe I'll do another one where we're close up on one of them. These are pretty good, though. You can see where all of the reproductive processes are. Are there any sunflower diatoms? Not really that have that sort of a structure that sunflowers have. But there's some that kind of look a little like sunflowers. Kind of excited to have the temperatures warming up a little bit now here in Indiana, so I can go out and take some photos. I was thinking I might actually just sort of blow off some of my workload this afternoon and go do some photography outside. We'll see. I've got so much grading to catch up on. I feel like I need to get at it, but...
And Jake Programming wants to know, can you see the mitochondria within the diatoms with your SCM?
Well, one, everything on the SCM is in a vacuum, so we have to get rid of all the organic matter before we start, typically. And if it were present, it would probably make it hard for us to see anything else. But mitochondria, usually, if you want to look at them, you have to have a TEM rather than an SEM. It's a little bit better at seeing sort of internal structure, cellular structure of organisms. The SCM's pretty good at topography, right? So the skeleton of the diatom is pretty easy for us to image. This is an internal view of a Stephanodiscus. We can see all the ultrastructure pretty well of the skeleton because it's rigid. But, living material in there usually doesn't look very good. It just ends up being like a pile of goo. And so it's challenging to see it clearly. Probably with a TEM you could see a lot more of the detail, but you're also looking through the sample rather than looking at its topography. But my guess is we probably couldn't see it, or we could see it, but we wouldn't know for sure what it was. So, because we can't get inside of the diatom. And, to look at the cellular components, we'd have to crack the diatom open somehow.
So like a micro diatom cracker?
Yeah, they have things that are like that. I don't have one. This is face photo Portula, yeah.
So we could do funding for a diatom cracker.
a drive stream, funding stream. You could give it a shot. Guess I wouldn't complain, but I think it's a lot of money. More than we could probably pick up on Twitch. Well, I think the thing is, Open said, P-Chops actually has the asteroid, and that's where all the gold deposits are. So he's got the billions because he has the asteroid. So I think you gotta have the asteroid first. Then you could have the $1 or whatever it is he has. Hey, the little star worked as the emote that floated through the channel. I still haven't figured out why some do and some don't. I see your comment, Pandemic Watch. Some diatoms may be like crocs or sharks that remain unchanged for tens or hundreds of millions of years. I think that's probably unlikely. I think diatoms are probably there. I can't think of any that are like that stable.
Good news, everyone!
Thanks for the follow. Alistair. I'm not positive about like the longevity, like the sort of unchanging diatom through time. I can't think of any that are like that. That are just like nothing's changed enough about them to actually make a new species. I think pretty much all of them that are really ancient are pretty different than everything that's living today, at least at the species level. Let's see, what is the...
Well, that was the... Oh, sorry.
What's the average life cycle time for most diatoms? It depends. So, you know, like they go through this sort of size diminution series, and that process probably takes, for most of them, something like 2 to 5 years. So, you know, they switch to sexual reproduction every 2 to 5 years to regenerate the size. So some of them it's probably every year, if they go through enough replications, or their total size group isn't that big or whatever. But it's more that diatoms are, I guess they're very squishy with respect to like their evolution. Like, it doesn't seem to take very long for them to evolve. So I don't know. When we have evidence of, and I have evidence of diatoms evolving over the span of 4,000 years, like from one species into something that's entirely new. So the actual evolutions are much faster than that, but the total evolution time from one species to a whole nother species is, you know, something like a couple thousand years, 4,000, 3,000, something like that. And this diatom that we're looking at, actually, right here, Stephanodiscus niagari, or maybe it's not, but it probably is close to it. It evolved in Yellowstone Lake into a new diatom, which is Stephanodiscus yellowstonensis, and again over the span of about 3,000 or 4,000 years. So that's some work that my advisor Sherry Fritz did with Ed Terrio and some other people. But yeah, pretty short lifespan with respect to how long they stick around, for most of them probably. What were you going to ask me, Pack? It's got one...
Oh, I was just going to... so I put a link in for the Diatom Web Academy on that diatom.
Oh, the evolving one? Yeah. Stephanodiscus caruscus, that one?
Yeah. And then the living fossil piece, because there was that article that you posted in your Discord.
Yeah, so that piece is associated with that same species. It's sort of an interesting one because when I first found that in June Lake, I was working with one of Mike's students again. They collected these cores, and I was like, "Oh, this is an interesting looking diatom." I tried to figure out what it was, and then yeah, the only thing that it even looked closely similar to was something that was supposed to be extinct. So I was like, uh, I don't know what to do with this. So I started talking to my colleagues about like, what do you do if you have something that's supposed to be gone, like completely gone? And really, the difference between the species, between the ancient one that supposedly died off, a million years ago or more, and the one that we have is just the absence of the valve-face photoportula, and then just a little bit of differences in the size series, like the sizes of the diatoms. So it's kind of interesting, but I mean, like, that's not a huge transformation. It's enough we probably would call it a different species, but like in terms of going through time, that's a pretty minor change to just basically have a process on one and then missing those processes on the other. So macro versus microevolution, it's probably on the microevolution scale. I want a nice picture of that Bedanocoid, but I haven't been able to find any of them since the first stub that we were on. It's a pretty uncommon little guy.
Pandemic Watch was saying, so diatoms are more like fruit flies than crocs.
Probably. I mean, you wouldn't think that they, like, they have sort of a interesting life cycle history because it's mostly asexual reproduction, and then they just have like a option for sexual reproduction in there, right? So you think about like there's a clear reason why organisms would want to have a sexual reproduction loop in there, because it allows them to adapt. That's the whole point of sexual reproduction, is that you can basically adapt to the environment. And I think that without it, a lot of species would probably go extinct, or they would have a hard time managing the environment that they're in, at least. As long as I guess if the environments are pretty similar, they'd be fine. But they might eventually get overtaken by something else, right? Something comes along and can be better adapted to that environment. It probably would be. So that's a consequence. But that having that sexual reproduction cycle in there gives them an out, a way to adapt to the environment, to stay on top as the organism best suited to that environment potentially. And so it's interesting that they are still able to evolve pretty quickly with they don't really undergo sex very frequently, relative to the number of times in a generation that they go through asexual reproduction. So, but it seems like it's still enough for them to evolve pretty quickly. So that's why I was saying they're kind of squishy. They're plastic. They're able to kind of undergo evolution relatively quickly. And look at this. Other freaky thing that's going on in this sample. Hang on. I can't get this thing to sit at the angle that I want, which I think is like 95, maybe?
It's
I
like
don't know.
Freaky Diatom Day.
It's the same freak, actually. I wanted to say, remember earlier we won the lottery. Here's the lottery again. So that's another initial valve for Alicocera. It's on its side. And you can see how hemispherical it is there, right? And actually, maybe I just want to zoom out a little bit. So you can see this is the Alicocera that goes together with that initial valve. And there's one over here as well. But this is something that happens with diatoms that because when they switch to sexual reproduction, like the whole generation usually switches. So when you get a sample that has an initial valve in it, you usually get more than one, right? And here's an example of an initial valve, I think, for Alicocera. Again, these two are linked together. It's kind of cool. Okay, I'm gonna take this picture.
It's very cool. And Pandemic Watch was saying environmentally induced timing, changing conditions across ages of Earth led to extreme changes in these genera, I assume. And that they're learning about the Wood Wide Web and the mushroom underground tree internet.
I don't know about an internet, but mushrooms and trees are pretty interesting colonial structures. So in my Dr. Mo VTuber lecture for this week, we talked about longevity and immortal organisms, and one of the most interesting of those immortal organisms to me were the colonial organisms, the trees and the mushrooms that have a shared stolon, the bottom part of the underground component that connects those pieces together. And it was actually so I have to do a lot of research to present those lectures, and it was actually one of the most interesting parts to me was that there's this mushroom that's 10 square kilometers large, basically, because the underground mass is really huge, and then the parts that are above ground look like individual mushrooms, but in fact it's all one big organism. And there's a tree, the pando tree, the quaking aspens or whatever they are, that basically also have like one giant organism, right? And it's connected. You're just seeing like the trees are just like the surface expression of them. And that was really fascinating to dig into for me for those lectures. There's a lot of, when I write a lecture, any lectures that I ever put together, you learn a lot from that process. So it was kind of cool. Yeah. Yeah. The panda one is the one that's pretty cool, and yeah, it's being protected right now. Hey, Jurgling, how's it going? We're looking at diatoms in the SCM. Who knew? We found a initial valve, which is like winning the lottery. We'd won twice. Did I get into box jellies at all? Those organisms always fascinated me. I got into the immortal jellyfish. I talked about it. And I talked about Hydra. And I didn't talk about the rest of the jellies. I don't know. You know anything about box jellies? Pacific?
Jellies are just bizarre, interesting creatures.
In general.
Yeah.
They always kind of weird me out because they are like a bunch of little organisms living together as a big organism, right? I mean, all those things are kind of weird to me. I mean, the trees are the same way, you know, in a sense, right? They're just like connected little organisms, but the jellyfish seem more like independent components that are living as a colony than other things. I don't know, they're super weird. So before I was like assuming I was looking at an Oligosyra initial cell, and I just sort of told you that it looked like Oligosyra to me as my explanation for how I knew. And because I hadn't actually seen initial valves sitting out by themselves before. But if I had any doubt before, I have no doubts now. And the reason for that is if you look at this thickened piece of silica that's running around the outside edge up here at the top, this thing up here is on the inside is connected to the ring least. So this is the column on an Oligosyra valve, this sort of little piece here. And it's connected to on the inside to a structure called the ring least, and that is exactly what's going on there. There's a ring least and a column. So I usually when something seems like that's what it is, and in this case it is. So I wasn't really doubting that it was an Oligosyra, but if I had any doubt, that would have put an end to it right there, because that's the Oligosyra are the only thing that have these sort of structures in living populations of diatoms. So some of the ancestors to Oligosyra also have those. So
Good news,
we're looking
everyone.
at something older, they would also have them, but for living populations, Oligosyra are only ones with ring leases. Hey, and we got a new follow, Wilson137. Thank you for the follow. Box jelly has more developed nervous system than most jellies, and oddly, it's mostly separated into two separate nervous systems. Oh, that's cool. Yeah, that's cool. Yeah, the fun part about those lectures is I get to sort of explore things that I think are interesting, and I mean, I guess I always get to kind of put together lectures that are about things I think are interesting, but these are more like delving into things that that I think are just fun, and kind of learning enough about them so that I could explain them to somebody else. So it's a you know, it's a lot of work, but it's kind of fun to do. So and this coming Thursday I'm going to talk about the neuroparasites, so that's also going to be a really fun lecture for me, but also it means I need to learn a lot between now and next Thursday about neuroparasites, because I know examples of zombified organisms, but I don't understand necessarily how everything works, right? Like, you can learn about organisms that control other organisms, but like sort of being able to explain how it works is a different level of understanding required.
That is beautiful. It almost looks like a mushroom.
This
Cap.
one? Yeah, like a little cap
Yeah.
of a mushroom. Yeah. Well, they're the end caps of the population, so in a way. And then you can see this really nice pinnularia here with a little bit of clay on the surface, but you can see those costi on them.
OpenSet says, speaking of immortality and cell death, had a cell bio friend injure her toe really badly in a trail run. Then she told everyone she had, apoptosis.
Apoptosis? Is it a joke? Was that a joke? Apoptosis is when cells are programmed to die, or like they intentionally kill themselves off. But there's a toe joke in there, I think.
And Fronature says, hello, sir. I saw you at Glorgana's channel and found out about your channel.
Oh, that's awesome. Yeah, I like hanging out over there with Glorgana. She's when she's not doing really gross stuff. Not that I probably couldn't handle the really gross stuff. I just don't want to. But she's highly entertaining, and I think we raided her last time we were on. So took some of my people over there. She does sort of taxidermy. For people who don't know Glorgana, she does taxidermy like live on Twitch from her house. So that's dedication, to bring dead animals into your house and reassemble them. I guess you also have to like clean them and everything else too, right, to even get to that point. So I think if I took that on as a hobby, my wife there'd be some, I don't know, I guess I'd probably have an outdoor lab at that point. I'd have to move into the garage or something. There's a student here on campus who does her own like collecting, and I guess she must have a permit for it or something, but collects roadkill and does some sort of taxidermy with it. And her kids aren't very happy about it.
All right, Rodriabala says, hi, how's it going? And Open Set says, easier to bring dead diatoms into the house than dead animals, I imagine, outside the cooking context.
Right. Well, there are some dead animals that are in with my dead diatoms, but and also some live animals, I suppose, but they're too small, and I can just put them in a plastic bag and they stop smelling. So I'm not sure that's the case with like a possum or a bird, and I can also just put sprinkle a little acid on them and make them not smell anymore. That's what we do with the stuff Pacific Plankton sends me. Well, it's a little more than sprinkling it, but it still gets rid of the smell.
Now, what is that one?
This is star anise, and so that's the genus star anise. And you want me to type it up before you do? I'm in the channel. I don't have to look it up. There we go. And I think actually I'm going to click on that link because I know the species for this one. I just can't remember the name of it. It's like on the tip of my tongue. I need the... Oh, this just opens the guide by itself. That's kind of interesting. It's like this Smithy eye one up here. Yeah. It's like star anise Smithy eye or Separanda. You can sort of see those. They have sort of the similar shape. Like a wavy, pointed ends. And this is Pseudosepta. Remember we were talking about Pseudoseptas? I think maybe that was the last stream. It's got like a little lip that sticks out over the rest of the diatom. And you can tell it's star anise because they have this structure called a staros right here, which is like a thickened piece of silica that other diatoms don't have. So other similar diatoms don't have. So in the light microscope, this is really clear. Like literally, it doesn't have any striae on it, so it's like a clear section. I'm trying to identify the bird in the background that I keep hearing on your microphone.
Uh-oh. So Fur Nature asks, could you explain to a non-native English speaker what you're doing? Specialize in? I read your description, but I have trouble understanding it.
I can try. So, you mean like what's my actual like specialization? I'm a paleolimnologist. What that means is somebody who studies lakes, and in particular, I look at sediments from lakes, ancient sediments or relatively modern sediments from lakes, and then and after that, I'm basically just kind of like a paleontologist in a way. You take the mud from the bottom of the lake and look through it for fossils, and basically use the fossils to tell you something about the type of environment that they lived in. So we can use the modern diatoms to tell us something about how ancient diatoms probably lived. As an example, this diatom that we're looking at right here, it's a type of algae. This is just the skeleton of its cell wall, which is made out of silica. And so if I knew something about star anise, which I do, they are usually motile, which means they can crawl around. Then I know it had to live on the bottom, I know it had to live where there's sunlight, and I know that it was basically capable of crawling around in the environment that it was in. So, we can take a sample like this from sediment and basically figure out, like, if there's a lot of these, then it must have been pretty shallow. If instead there's a lot of these big round ones, which there are, then these things like high phosphorus and relatively deep water. So, I can tell something about, if you handed me a sample, I could tell you something about the type of environment that it probably represents from the past. I don't know if that is understandable to a non-native speaker or not, but that's what I do.
So Rodria, I'm going to pronounce this wrong, I'm sorry, Rodriabala wants to know, can you somehow predict how diatoms will evolve in next generations based on their environment?
I guess probably not, but I don't know that anybody's ever tried to do it. We don't do a lot of forecasting. We're more like hindcasting most of the time. So, if you wanted to try to predict, like, based on how they have been, like, what's the direction that they've been moving in, with respect to the change in their shape and whatnot, it would require you to have a pretty clear understanding of which species evolved into which species, which then evolved into which species. And I don't know that we have that. I don't know that we're there yet. But if you could, and you did that, you might be able to sort of project. There's a really cool software tool that I use called landmark analysis. When I'm trying to figure out if I'm looking at one species or two species or three species or whatever, I have a population of them and I'm looking at them and I'm trying to sort them out. And it does sort of a shape analysis. And one of the things that's kind of neat about it is it sort of shows you, like, as the species size series changes, their shapes are slightly different, like as they get smaller or bigger or whatever. But if you had a whole bunch of species, it creates this sort of artificial space where it shows you where they plot, and then if you move your cursor around, it will actually show you what the species looks like, right? Where the landmarks are, where the positions are that you've selected. And then you could move your cursor into places where there aren't diatoms. Like, you could go put it into some place that's like magical, non-existent diatom, and you could see what it would look like, right? It gives you like a sense of, here's the things that are moving as it evolved or as it changed. And then here's something that's out in this sort of magical, non-existent morphological space. And I do that sometimes. I just move it around and say, like, what if it was in this corner? What would it look like, right? Just to sort of see what are the controls that are changing. But you could use that if you could actually see the evolution. You could probably then project it's going in this direction and then put a dot out there somewhere, and it would draw a non-existent diatom for you. And you could, you could have a, unicorn diatom, some imaginary diatom. You could do it with anything.
It'd be fun to see that.
You could do it with anything, actually. Anything that has a shape that you can put specific landmarks on. You could then say, well, look, it looks like it's doing this, so like here's where it would keep going if it were growing in that direction.
Well, speaking of growing in directions, it is noon here, and I have people to feed.
Mm-hmm. Figured that was going to happen soon.
Have you eaten?
I have not. And it's only 3 o'clock, so... I did have a little bit of this Coke, so,
Well, I suppose that's some sugar.
Right. I did have some low-grade calories.
Well, it was a lot of fun hanging out. I'm going to have to go, though.
Yeah.
I'll be lurking and listening. I just won't be speaking.
Yeah, it's fine. I'm only going to stream for another 20 minutes or so anyway. So it was really nice having you here, and thanks for hanging out and handling chat and all the other things. Moderating.
It was a chill morning. Thanks
Yeah.
for the stream.
Sure. I guess we could also give one of these in there for Pacific. Let's see, what else could I do? I think I can get rid of the... I'll just leave it running. I don't really need the marker telling you when I'm talking. You can see my mouth moving, probably. Okay, so I'm just going to look around a little bit more, see what else we can find before I shut it down for the day. Maybe do a little magical birding with my camera. Be nice to get a little bit of time to do some photography. It's like my favorite hobby next to using the SCM, and be starting to warm up a little bit so we can go out more frequently and take some pictures. We saw this one already on the other sample. It's the same diatom we imaged earlier. Well, I'm going to jump over to 4. Let's just see what's there. And it's more of the same, but maybe we'll find some of these little guys that I've been looking for. Like maybe that's one. I'm trying to find someone that's some diatoms that are in this size range. Looks like this is the right species, but it's got like a boulder sitting right in the middle of it. We could at least image it so they have some idea of what we're looking at. And I could maybe zoom in on these Valface photoportula a little bit so we can see them. These ones are kind of neat. They are the center tube right here. And then there's 3 pores associated with every one of these. And then there's a sort of a triangular shaped cover that goes over the top of them. So it's a little confusing to see what you're looking at, but that's what that is. There's a little extension that covers over the holes. And then each of the holes has a little sort of edge or berm around the outside edge of it here. So you can see that structure right here. They're like pizza tables or something. That's the way they kind of look. And I'm going to slow it down a little so you can really see that structure. So it's got this sort of little triangular shaped pore cover. But then I also am going to play with the stagnation just a little bit more, see if I can fix it. Worse. It's pretty good. And I'm just gonna line it up, and then I'll take a picture and come back to chat and sort of see what's going on. Bob Ross Diatoms edition. Get a lot of Bob Ross comments. I'm going to get myself one of those big Bob Ross hairdos so I can complete the Bob Ross sensation for you. I like that emote. It's like a cat with a covering over its head, like a blanket or something. Let's see. Rod says it amazes me the kind of shapes we can find in nature, and I think diatoms are one of those things where they've got a lot of really interesting, charismatic shapes. I think that I could get an even sharper image with AI taking multiple samples. Let's see. Well, it's possible that you could get a sharper image with multiple, collecting multiple images of the same shot, but the likelihood that a robot would do a better job of focusing is probably pretty low. It might be a little bit more convenient for me, but it probably would be incapable of figuring out which one of these heights is the one that I want to sort of see the right things. It could take a whole stack of images and then use image stacking to put them all into focus. That's an option, but let's see. Fronature wants to know, has it ever bothered me that there's a large upload time? So it's not actually uploading. It didn't take a picture and then and then upload or download the image. It's actually building the image as we go. So if I stopped it right now, it wouldn't collect the information from the bottom part of the figure. So there's no image. It didn't take a picture and then it's just slowly uploading it. It's actually building it as we see it. That's the scanning part of the scanning electron microscope. So, and its speed is based on the speed setting that I select, which is directly proportional to the resolution of the image. So, for example, I will just give you an example here really quickly so you can see what I mean. Okay, so this is the image we just collected, and the speed setting that I have it on is 7, and I'm going to put it on a speed setting of 5. So this is speed setting 5. If I went to take this picture, it's the same picture, right? Except now I have a faster speed setting, and I click it. This is the picture that I get, right? So see how quickly it's happening. It's going to be 20 seconds to collect the image. but it's grainy, and the reason that it looks grainy is because as it scans, it's producing the same amount of information, but it's more widely spaced out. So it can complete that picture pretty quickly, but the image quality is not nearly as good as the image quality that we had before. And it's not because it took longer to load the image or anything like that. It's just has to do with the speed setting that the image is on. So if I were to put it on speed 2 and do it, I would get a picture that looks like this. And if I were to do it on speed 10 and take the picture, so this is the slowest speed that the instrument has. The line down here is for 10, and you can see it started back up at the top. But just to give you some sense of like what it's doing is it's collecting information at each one of those spots, but it's sampling at a much higher density now. And imagine having to wait for this picture to go all the way through, right? So it's building that picture just line by line, increment by increment, but it's basically a smaller increment that it's building it. So it's a higher density of points of information that it's producing. And if I were to collect the picture right now, it would take us 91 minutes for it to complete that image. So like if I started it now and I went home, had lunch, came back, it'd still be going. So it doesn't have anything to do with like the downloading. That's just a perception. Like we perceive it as being downloading, but it's not actually downloading the image at all. It's building it. So does it bother me? No, not at all. I don't mind it. And if I wasn't streaming while I was doing it, it still wouldn't bother me. Because I know that the quality of the image is determined by how long I let it, collect the image for. So, the positive for me on my side is when I'm not streaming, it lets me work on answering emails or doing other parts of my actual job. Like I can start it going and then get distracted, check my phone messages or check my email or grade something, while I'm waiting for it to do stuff. And while I'm streaming, it's actually kind of nice because the streaming part's a lot of work, and I can't actually like manage the SEM and the chat at the same time. And if I were to try to, it would just be distracting. So from my perspective as a streamer, I actually kind of like having it take a little while to take the picture, because then I can actually read chat and interact with people, which is part of the streaming, sort of experience. I don't want people you're not just here to watch me do stuff. Hopefully you're here to at least take a look at the SEM, but you probably want to actually like have me answer your questions and see what you're typing and stuff like that. And I can't do those things if I'm entirely just working on the SEM. So from my perspective, it's actually positive. Maybe from the perspective of people who are watching the stream, it's a little less enticing to have to wait to see what the image is going to be. But I also feel like it's kind of nice to have it constructing it as you're sitting here, because you can actually like see what's going to happen, what's going to build, and there's a little bit of anticipation. But I'm not a immediate gratification kind of a person, I guess. I'm willing to like let it be long enough for me to kind of like wait for the image to completely form. So it doesn't bother me. It helps set with the pace for the stream, I think, or for whatever else I'm working on at the time. So sometimes you just kind of have to be patient, and I'm naturally a patient kind of a person. So still pretty sharp for a 5. I don't think it would be very good, though. It's not quite as good. Scary cat you have open set. We can just turn it up to a 9 or 10. Yeah, if we want to get crazy with the sharpness, we could. And I can actually lower the beam intensity, which changes the spot size. But I feel like this is a good trade-off for, you know, the quality of the image. So this is a nidium that we're looking at. The quality of this image is really sharp, and I think it looks really, really nice, and I could publish it if I wanted to. But then I'm also going to probably turn it into something for Instagram or share to people on my Discord and Instagram. And so from my perspective, I mean, if I was just trying to get like a quick and dirty image, I'd put them on 6, right? Okay, so usually I run at 7. It's a 3-minute image. Yep, and higher quality basically requires lower speed. Yeah, right. Let's see. Can you somehow save the coordinates so it's back to that position later on? It takes higher quality images. Yes. In fact, you can't see that window, but on my SCM, there's a separate control panel. I could maybe put it on the stream, but it's not very interesting. It just has like the carousel numbers that I can select from, but then it also is the thing that I'm typing in to cause it to change angles and tilt and whatever else. But it keeps an X and a Y as well as a Z value. So I could come back and image them after the stream, but part of the purpose of me streaming my work is that I don't have to do something for the stream and then go back and spend hours later like redoing that same thing. So that sort of defeats purpose from my point of view. So, right. How many megapixels is the image? So up at the top, it actually tells you what the resolution of the image is. This is 1280 by 1280. That's for pixels. By pixels, it's a square. If I wanted to, which I don't, usually, because that's a huge picture, right? 1280 by 1280 is a pretty big picture. But if I wanted to actually have a higher megapixel value, I could get it. I don't want you to think that the SCM is limited in any way with respect to resolution, because it isn't. There's parameters up here that I can change for the image itself, and my choices are like if I click on image parameters, I have the viewing live window is at 1024 by 1024, but if I wanted to do the save value, like how big I want the image to be, it's currently set on 1280 by 1280. I've got settings for 1536, 2048, 2560, 3072, 4096, 8192 by 8192, or the top one, which is 16,000 by 16,000. So like 16,000 pixels by 16,000 pixels is a pretty big image. But the problem is, as I raise the image resolution and it makes a bigger image, it takes longer to collect the image. So I could take smaller pictures at lower resolution, and it would be a little bit faster. Or I could take smaller pictures at higher resolution, it would be roughly the same quality. But the bigger I make the image, the higher the resolution I get out of it, the longer it takes to collect an image. So there's trade-offs. And for me, the way that I have it set up now is basically optimal. It gives me a relatively good image without forcing people to wait all that long to see what I'm doing. And also, I get a quality image when I'm done that I can use for my own purposes. And I could make it smaller. It would save us about a minute probably, or a minute and a half per image. But also then I would have a minute less I could interact with people and see what they were saying. And so like I said, that part of it is actually just the pacing that I like. And it makes it easier for me as a streamer. If you were watching a musician on Twitch, which I'm sure some of you do, well, in fact, I know some of you do, between songs, they can talk to people, and the rest of the time they can't. But you wouldn't tell them, hey, could you just play shorter songs so we could talk to you more? That's basically the equivalent, right? Or if you were drawing something or whatever else, right? So, but the pacing is pretty similar to the way that musicians have to kind of pace things, because, you know, they can work for a little bit and then collect an image, in my case, or play a song for a little bit and then stop and talk with people, in their case. So it's always like just part of the pacing. So we run at a slightly slower pace here, and I'm okay with it. So I guess it could get more images, but they wouldn't be as nice. And I think that probably that would be a sacrifice I'm not typically willing to make. So this is a Pinularia. Last one we took a picture of was a Nidium, and I don't know what species this is yet. The sample that we're looking at is from Jackson Lake. I haven't mentioned that in a long time, so if you came along later in the stream, Jackson Lake in Wyoming, and I'm imaging some samples for actual scientific analysis. So this is, it's not just for funsies. It's also fun, but I'm aiming to help characterize this species for a PhD student who's working on analyzing a core from this lake. And then I have a master's student who might also be working on one of the cores from this lake. So these pictures will help us basically figure out which species we're looking at, and if we want to publish, basically, if we find something new, or even if we find something old and we want to publish the images, we can if we take relatively high quality images. So I guess that's part of the reason why we're operating at the speeds we are. So probably we'll have some more fun streams coming up now that we're getting a little bit nicer weather conditions, but where we look at some random things like pollen or flowers or insects or something. Those will probably come soon enough, now that we're getting kind of nicer climate. We actually have bugs and flowers opening up and stuff. So I'll try to do something that's not just diatoms occasionally. Next week, I think for Wednesday, we have looked at fungal spores before, open set. I have some in my Instagram images, but we'll look at them again. We looked at both like the undersides of mushrooms, but we've also looked at, oh, there's one right there in the little picture, like in the slideshow it went through. We've also looked at the slime molds as well in the SCM, the spores from a slime mold. Anyway, so for next Wednesday, we'll probably be looking at some more ashfall stuff. I think maybe I'm going to have both Joe Mohan, who was here last Wednesday, and also Mark Edlund, who's the author of the paper that Pacific Plankton, well, the little story that Pacific Plankton brought up. And I think they'll both be here. I think that's the plan anyways for next Wednesday. And, they'll be telling me what they want pictures of, basically, and we can take a look at things. It'll be nice because Mark's actually a diatom taxonomist. I sort of do diatom taxonomy, and he's more like, that's his actual, like, primary training. So, and he's sort of my taxonomic guru. When I have questions, I usually ask him. So it'll be nice to have him on, and probably be a neat experience for him to actually interact with people. And then I also have some stubs that Addison has made, so we might actually end up streaming like a longer segment of Wednesday. I'm not sure what we'll do there, but she also wants to take a look through some of her samples from Clear Lake in Iowa. So
Good news, everyone.
Thanks for the follow, Wu Type of 7. And, okay, so I think this is the last image I'm going to collect for today before I can go get something to eat. And it's another pendularia, as I mentioned. I'm just going to call it species 2. I don't know which actual pendularia it is. I don't know if it's actually one that we saw that was similar to the one we saw before or not, but I don't think so. And then, yeah, so I think we'll probably go raid somebody now, which means I need to find somebody to raid. I will take suggestions if people have them. Let's see who I have that's on. Let's see, we could raid. Let's see, last Saturday we did WD-40, so I think maybe we will go with Freckled Science. So let's see what she's doing first.
And like this whole week has just been pulling all night speaking from what?
Sounds like she is doing science stuff. Lots of good people to raid depending on what you're into. Well, if you have a suggestion, I might take that open set if you got somebody else in mind. If you do, now's the time to speak up. Let's see if I can find something to look at while we're trying to figure out who will raid. So, Freckled Science would be a good choice. She's always doing something fun. But we've also raided her before, many times. So, we could go in there, or we could find somebody else. I'm totally fine with whatever. Largely debris-free Stephanodiscus that we have here. Oh, you know what? I think I rated this Takayoshi before, and they were doing something that like you couldn't even see that we had rated. I mean, I'd be okay with that. I don't mind. Either way, it's still somebody interesting and new. Yeah, we did Dr. WD-40 last week, so I like him, but I like to also try to different people out, so we'll go with the Takayoshi. See what they're doing. Hopefully they can actually interact with people, but I mean, if they can't, I guess they can't. Okay, I want to thank everybody for hanging out with me today, and I'm going to just go ahead and collect one more image because I can. I set it on a 10-minute collection, so it'll do that while we're getting ready to raid here. He is talking to chat. Okay, good. So, and he's a harp player, and I think we watched him play a little bit before. I want to especially thank Pacific Plankton for hanging out with me in chat, and OpenSet for hanging out and moderating the channel, and Devil and Mrs. J, hopefully somebody gave you a shout out. You did, okay, good. And Pandemic Watch, thanks for hanging out. We had a whole bunch of people hanging out for a really long time today, which is nice. Okay, well, this is building very slowly on the image, so we'll raid long before we'll actually get to the end of that Stephanodiscus. But thanks everybody, and we'll catch you on Wednesday, hopefully with Mark and Mike, or Mark and Joe here. Okay, it's getting ready to go, so we'll see you later. say bye now.
Taco Bell's quesalupa is back with its cheese stuffed shell. But there's nothing worse than